Hello everyone and welcome back to the channel. Today we have a very interesting machine learning project which is predicting the winner of the Premier League for this season. As the Premier League is getting really tough and only 1 point between the top three, Liverpool, Arsenal, Manchester City, some of my friends asked me to build a machine learning model to predict the winner of this season. So let's see if this is something easy to do or not. So first we need to get the data for the past 10 seasons, which is not for free. Next, we need to build the machine learning model, to train the model, to evaluate the performance of the model, try to improve it as much as we can, and finally, to try to predict the remaining games. And finally, to know who is going to win the Premier League for this season, according to the machine learning. So let's get started. So first, we downloaded the data from 40 stats for the past 10 seasons. So each season is downloaded individually. So you choose the season, the league, and then you go and download the CSV file. So this is how the data looks like. You have the home team, the away team, and then you have the goal count, home team goal count, away team goal count, and then the total goal count. And there is a lot of information. You have the date of the game. So this is for the past 10 seasons. We compiled them together. So we have the data from 2014 until May 2024. And you can see this is the incomplete games, which we will be trying to predict. So this data was until the 31st of May, and then we will try to predict after that. Before we load the data to Python and start coding, I just remove the columns of the goal counts and replace them with one column, which is the result, if it is a lose for the home team, if it is a draw for the home team, or if it is a winning for the home team. And also I removed some irrelevant columns for our project. So we will load this data and we will start coding. Now let's start coding. First, we need to import some libraries that we will need. So we need to import pandas to work with data frames. From sklearn ensemble, we need to import Random Forest Classifier. So this is going to be our machine learning algorithm that we will use for the prediction. And also from sklearn metrics, we need to import accuracy score to evaluate the performance of the model. Now let's load our data into a pandas data frame, and then to make sure that the date column is following the standard pandas date format. Let's run this, and now this is our data loaded into a pandas data frame. We have the date column, we have the home team name, away team name, we have the result if the home team is losing, or if it was a draw, or if the home team was winning. And here also, as you can see, we have the games that are incomplete, and that are the ones that we will try to predict. And also, as you can see, we have 3,800 rows. That means we have 3,800 games, and we have 33 columns. So we will be trying to use some of this information to do the predictions. If you go here also, you have the stadium name. There's a lot of information. We will see how to use them to do the prediction. Now let's take a look at the data type in each column. So dataframe.dtypes will give me the data type in each column. Remember that machine learning algorithms can work with only numeric data, like the float64, the int64. But we have some columns here that are having the object data type, like the home team name, the away team name, the result column. So we have to prepare these columns and to convert them into numeric data before we move on and start training our model. So for now, we will choose these two columns, the home team name, the away team name, which is the basic information, the result, and also the stadium name. And we will convert them into a numeric data. So let's go ahead and do this. Just copy and paste this. So for the home team name column will be converted in a new column. We'll call it as a home team code, and it will be converted into a numeric data using the .cat.codes. Similarly for the away team name, similarly for the stadium name. And here also from the date column, we want to extract information about the day of the week. Maybe some teams are playing well in specific days of the week. And lastly, for the result column, will be converted into a new column. We will name it as a target, and that's basically what we will be trying to predict. And we will convert it into 0, 1, and 2. So 1 for winning, 0 for losing, and 2 for draw. So let's go ahead and run this. We should see 5 new columns in our data frame. So if we go here, yes, so now we have the home team code, away team code, stadium code, day of the week, and the target, which is basically the result. So for example, team number 14 was playing against team number 9, at the stadium number 24, at the 5th day of the week, and the result was a draw. So these all numeric data, and this is what we are going to use to train our model. Now let's split our data into a training dataset and testing dataset. So our training dataset will be for almost 8 seasons. Remember that our data frame contains the data for 10 seasons, starting from 2014 until the end of this season. So our training dataset will be everything in our data frame before 2022 August, and our test dataset will be from 2022 August until today, the 1st of April. After this date is going to come later in this video, which is the remaining game of this season that we will try to predict later in this video. At the moment, we are still training the model and testing the performance of the model. Next, we will build our model, which is a Random Forest Classifier from sklearn. And then we will pass the predictors that we have created to the model. So at the moment, we are using only 5 basic predictors, which are the home team code, the away team code, the stadium code, the day of the week that we have created here. Remember, we have created these basic predictors here. And also I'm adding one more predictor, game week, which is the week of the year. This is in the original data, game week, and it's already integer. It's a numeric data, so that's why we did not add it here, because it's already a numeric data. So we will pass these predictors to the model in the training data set together with the result column. So for this information, for 8 seasons, this was the result, and we are training the model on this data. And after this, we will ask the model to predict the target column given also these predictors in the test dataset. And we will compare what was the target column in the test dataset with the predictions by the model to get the accuracy score. So let's run this and see how accurate is the model. And as we can see, the accuracy of the model is around 46, which is not good. So next, we will see how to improve this. To improve the accuracy of the model, we need to add more information as predictors. So let's go back to our data and see what we can add. So we have these 2 columns here, the home team point per game, and also the away team point per game. This data is already numeric data. So let's go and try to add these 2 columns as predictors, and let's see if the accuracy will improve. So we will add them here. I'll just copy and paste. And let's run this again. And as we can see now, we have improved the accuracy from 46 to 60%, which is not bad. Let's take a closer look on the confusion matrix to understand the performance of the model. So this is the confusion matrix. So when the actual result was that the home team is losing, 114 times the model was correct in predicting that the home team is losing, but 71 times the model was predicting it as win, but the team was actually losing. And 18 times the model was predicting it as draw, but the team was actually losing. When the team or the home team was actually winning, 275 times the model predicted this correctly as winning, and 31 times the model predicted it as lose, but actually the team was winning. And 13 times the model predicted it as a draw, while the truth is winning. This is not bad. So the model is performing very well in predicting the winning, but not really good in predicting when the home team is losing. Now let's try to predict the result for the remaining games using this model, even though the accuracy is not the best, but let's see. So first, we are creating a new data frame. We are naming it as future, and we are extracting from our original data frame the games that are after the 1st of April, which are the games that are remaining in this season. And then we are passing this data frame to the model, not the whole data frame, but only the predictors columns. Remember, these are the basic predictors that we are using. It must be the same predictors that we used to train the model. We have 7 basic predictors. So from the future data frame, we are passing these predictors to the model to predict the target column, which is the result. And we will save the results into a new column in the future data frame, and the name of that column is predictions. And after this, we will extract only the results for Liverpool, Arsenal, and Manchester City, the ones that we are interested in. So let's run this. And now we have predictions. And let's now extract from the predictions for each team. We want to see how many times the team was winning for each one of them: Liverpool, Manchester City, Arsenal. If the team was winning, so if the result is 1, this time times 3 multiplied by 3, so 3 points. And if it was a draw, so it is multiplied by 1. So we want to know how many points each team will make from now until the end of the season. So I'm interested to know the times that the team was winning or the result was draw. Similarly, for the three, all of the three teams, Liverpool, Manchester City, Arsenal, we want to know how many points each team will make from now until the end of the season. So let's run this, and the model is saying that Arsenal will make 18 points, Manchester City will make 15 points, and Liverpool will make 17 points. So if we add this to the current table, Liverpool is currently having 67 points, Manchester City is having 64 points, and Arsenal is having 65 points. If we add this, we can see that Liverpool will win the league with only 1 point difference from Arsenal. So that is what the model is predicting. If we want to further improve the performance of this model, what we can do also, that we can use more information from our original data frame, like, for example, the home team shots on target, the away team shots on target, the red cards, yellow cards, the corner counts, and so on. But we cannot use this information as a straightforward predictors like we did here, because we don't have access to this information when we want to predict the future games. Remember that when we use input variables as predictors, we need to use the same inputs when we try to predict. But for future games, we don't have access to this information. But what we can do, we can use something called ruling average. So for each row, for each game, we don't train the model on this information for that specific game, rather than the aggregated data for the past 3 games or 5 games, how the team was doing in the past 3 games. What was the average home team shots on target for the past 5 games? So in this case, we can train our model. So when we want to predict for future games, we don't have to provide this information because we don't have access to it, but rather than we provide information about the past 3 or 5 games or whatever. But then it will become also complicated that we cannot predict for 1 month ahead for the remaining of the season, rather than we can predict game by game. So let me know in the comments if you want me to do this in a second video, and also if you want the data for this project, I can send it right away to you.